There are a couple of ways to do regression, and the first way is the way we've been doing up to now, and that's the simultaneous entry of predictors. And that is that the predictors are entered all at the same time into the regression model. And then we just compare the B weights to understand which of the predictors is contributing the most to the DV. So I think this is the most useful when we have just one control variable and one variable of interest. So just in the two predictor case, for example, we would look at if we had a training workshop um, to change leadership effectiveness or to increase that, and we would want to control for these participants' pre-workshop levels of leadership effectiveness. So we want to understand, is our intervention working the way that we expect it to when we're controlling for what the participants already had coming in, or their baseline levels. So that's a really simple, elegant analysis, and sometimes that's all you need to have, and so that's useful. The hierarchical method is useful when you have more predictors and you have several control variables. And so at the most basic level, in the hierarchical method, predictors are added into the equation one or more at a time, and they're added in blocks or steps. So each block, and then at each block we assess the incremental change in R squared. So our research question for this might be something like, does my training workshop explain incremental variance in leadership effectiveness above and beyond a couple of at least a couple of controls. First one would be pre-workshop levels, as we had before. And then maybe we want to add years of leadership experience or gender for whatever reason if we think that's going to matter. So we would put all of these controls in block 1, and we would put the intervention in block 2. So there's a special causal priority or sequencing that's important with hierarchical regression. We want to add first the variables that were pre-existing. So of course gender pre-exists this intervention. So the person's gender existed before the intervention came into play. So we want to put that first in the sequence. Years of experience existed prior in time to the intervention. So we'll put that first in block 1 rather than in block 2. So typically what goes last in the equation is the variables that we're most interested in. So we're going to put the controls in first that we're not as interested in. They're not of our direct focus in the study. And then we're going to enter the ones that we really care about in the second block of the model. Okay, so, and again, all of this is to assess the change in R squared that we get. If we get a significant bump in R squared from the variable that we really care about, then we can say with more certainty that this variable contributes more to the DV than these other ones did. Okay, so that's the theory behind hierarchical regression, and there are some issues with it in terms of, Keith brings up some caveats to this. I think the primary problem or challenge that a lot of individuals see with hierarchical regression is that you can get such different results depending on which variables you enter first into the equation. So more on that to come, but that just gives you a little preview. Simultaneous, again, is more simple. I think it's easier to interpret in some ways. Hierarchical, typically you're working with more predictors, and when you have many predictors, things always get a little bit more complex in that case.